Okay, let's start. Hope you can hear me well. Today we'll talk about MySQL replication, what it is, and how we configure and use it. A little bit about myself. I'm Nikolay Antonov. Currently, I'm working as software engineer at Vektor.ai, platform that helps people to find mentor for them. But before that, I worked on Yandex Cloud. It's one of the biggest Russian cloud providers. And my team and I managed a lot of MySQL clusters, and we see a lot of issues with this and had a lot of practice. So it was a full-time job to fix, repair, and automate MySQL clusters. And today we'll cover start from short introduction about what is replication. Then we will cover MySQL replication basics, how it works, which topologies people use, types of applications, and so on. Then we will see how to set up replication. We'll see common issues and how to fix them. And finally, we will have time to discuss it. Okay, let's start. What is MySQL? MySQL is a really popular database, relational database. It's supported by big companies, by community. There are several forks, such as Percona server and MariaDB, that are completely open source, and you can use them for free. It's also supported by service providers such as Amazon and big clouds. And also MySQL has support for almost all programming languages, a lot of toolings, and it's a great product. According to DB Engine's website, it's #2 in their rating. I think that Postgres is a really good competitor for MySQL, and probably Postgres will, in my opinion, win this competition because it's got features a little bit faster, and the open source nature of Postgres makes it evolve faster. So in some future, I believe that Postgres will take over, but for now, MySQL is a great choice. Please use it. It's a great product. Okay, let's start from the very beginning and think about replication as state machine replication. What does it mean? It means that if you have some state machine that gets from some queue events, applies to state, and get a new state. And the idea behind state machine replication is that if we have same state machines, then we get in all events from log and replay it on another state machine. Resulting state will be the same. In order to achieve this, it's really important that every state, every event applied to state is deterministically, so there is no variety on how it can be applied. So if this rule works, it means that on all replicas you will have the same final state. It's what the replication means, basically. And if we apply it to MySQL, replication is mechanism of recording changes on source server and replaying it on replica server. Here I should tell that in MySQL, people used to call masters and slaves servers, and now they're trying to use another wording, source server and replica server. I will stick to master and slave because it's just more convenient for me. And yeah, why do you need replication for MySQL? Okay, I will check that. Yeah, I have a second slide. Why do you need replication? First one is scaling read traffic. When you have one master server, you are limited by performance of this server, and basically you cannot grow infinitely. You will be limited by the biggest computer, biggest server you can buy. So not all issues can be solved by such approach. So by replicating one master server to multiple replicas, you can spread read traffic across all servers, and it will work well. I've seen, I think, 17 replicas for a big online shop, and it works really well. Second idea why do you want to have replicas is high availability and failover. When master dies, and it's not a question of whether it dies, it's just a question when it dies, because computers are not reliable. Probably you want to have failover server that will get functions of master and continue working. This is why you need replication. Third one is backup replicas. When you're taking backup in MySQL, it takes some logs, and it can stop you from doing some DDL operations. So probably you want to make backups from a replica rather than from master, just not to stop master applying your changes. Fourth option is quite interesting. It's CDC. It's change data capture. Basically, you are reading traffic of replication. You can decode it and understand which rows are changing and which values are changing. And using this, you can feed this information to your application and get a feed of events, what changed in database. It's really interesting approach. Also, there are analytics and reports. Analytic queries, as you know, is really complex queries that can run for hours. And it also can have negative effects on your MySQL hosts, because if this run in a transaction, MySQL starts creating undo log that can grow to really, really big sizes. And it's quite hard to shrink it back in MySQL for historic reasons. And one small application for replicas is testing MySQL upgrade, or just testing. You can do crazy things with replicas if nobody looking at that replicas. Okay. Yes. Let's see how replication works on MySQL Master. It's really simple. We have several storage engines, InnoDB, MyISAM that is deprecated, memory engine, and others. Every time it writes data to the database, it produces binlog events that is written in separate files called binlog to the disk. Surprisingly, binlog service inside MySQL is the same model as a transaction manager. So all transactions are written to binlog. And on the replica side, it's a bit complicated. What replica doing? It's connecting to master host and asking master to produce all binlogs that it requires. Then it fetches and stores to disk and calls relay log. This is done by EO thread, separate thread that doing this particular thing. And second replication thread called SQL thread doing following. It reads relay logs from disk and apply transactions. It's enough to have replication working. There are more complicated scenarios. For example, if you want semi-synchronous replication, MySQL Replica will also notify master as soon as it's completely read these events. So master will be aware that at least one or at least several replicas read events, and it's safe to proceed. Okay, we already seen basic topology when we have one master and one replica. Events from master goes to replica, and that's it. We can have a little bit harder, complex topology, multi-slave, multi-replicas. It's when you need read scaling out. We can also set up replicas in chained replication. Sometimes it's called cascade replication, where intermediate replica will be called intermediate master. Sometimes it's have some meaning because when you have too many read replicas, you can go and you will consume all output traffic that master server can handle on this just replication, and then you will stuck. So you probably need some more complex replication schema. And last one is master-master replication. Sometimes it's called ring replication. It's when you have two hosts, both of them are available for write, and both of them are configured to replicate from each other. It's not recommended solution because basically MySQL doesn't have configuration, doesn't have mechanisms that will prevent you of getting replication errors due to modification of the same roles. And so please don't use it. Just know that it's possible. You will not get, probably you will not get any benefits in performance. And yeah, don't use it. And quite exotic version is multi-source replication. It's when one replica can replicate from two masters. I have never seen it in production. Probably the only solution is to, when you want several MySQL database merge into one host, so you will have several databases that replicates to a new one, and new one will work with all databases. Okay. In MySQL, you can have two types of replication. MySQL can write statements to the bin log. So you will set up a log bin configuration option as statement. It means that for every transaction, MySQL will basically write the same, almost the same SQL as you type in console or your application sending, with one exception. Any function call that cannot be not deterministic will be replaced by exact values. For example, if you have a SQL query of removing events that date is bigger than now is a function call, it will be replaced by exact date and time when this transaction is executed on master. So it will be safe to replay on the replicas, and probably you will get the same result. Unfortunately, it's not so reliable, and on MySQL website, you even can find a page when they list all issues you can face, and so it's probably can work, but it's not as reliable as you probably want. And to fix these issues, MySQL supports row-based replication. Basically, it means that for every transaction you're running, it will log to the bin log every row its updates. It's clear that, for example, for delete star from my table, it will produce may produce millions rows, and in bin log it will take quite a lot of space. But it's definitely more safer than having some random non-deterministic behavior. So basic rule of thumb, use row-based replication whenever possible. Second option, that supports different difference that MySQL supports is async replication and semi-sync replication. Okay, async replication is when MySQL Master writes some events to bin log, and then it's allowed for Master to say to their client that, wow, everything is done, it's okay, transaction is complete, and everyone is happy. However, there is a chance that if master crashes or network partitioning happening or something bad happening, this transaction may be lost because no replica read these events. And when some tooling will switch master, you will not have this transaction on the new master. It's maybe okay for some applications that prefer performance over reliability. It's maybe fine to lose some transactions, but usually people don't want to lose a single row. So MySQL also supports semi-sync replication. In fact, it's also async replication, but with one small difference. Master will wait until one or several, depending on how you configure replicas, will fetch these bin log events. And so if in case of master died, you will be on a safe side because at least one or several replicas will read these events and no transaction will be lost. Unfortunately, it means that your clients will wait a little bit more because they will wait for a network round trip from master to replicas and back. So there is a trade-off, and usually people chooses to have semi-sync replication over async because for software developers it's easier to think that anything they wrote to database is persisted and there is guarantees that no single row will be lost. Okay, let's see how to configure replication in MySQL. It's relatively simple. There are several steps you should do. First one, you should enable binary logs and configure it. So you should set up log bin to 1 or to true. Expire log days and max bin log size will prevent my master host from removing bin logs too fast. Set some value. Then you should set up server ID. Server ID is really important to set up, and it should be different on different hosts. So please be careful. Don't reuse server ID. Then you should create a user. You should create it on the master host in order to replicas be able to connect with this login and this password. And also you should grant privileges, replication privileges to this user to allow replicas fetch replication events, and flash privileges for all MySQLs just to ensure that your changes applied. From Replica. On Replica, it will be a little bit more interesting. First of all, you should create copy of master host. If you're installing your database from scratch, you will just have empty database. But in real life, it's usually not possible that master will have all events from the very beginning. So basically, you making backup of master, then installing this backup to replica host, and then configure replica to replicate from master. On slave, you should say from what server you should replicate. So you're using a command change master to master host master user password. And interesting part, you should specify which bin log MySQL server should use and which log position. Basically, it's offset in this bin log to use. Later, we will see that when MySQL configured to use global transaction IDs, you can omit this part and say that please use auto positioning, and it will work as magic. And last thing, you should start a replication by, well, it should be slave start slave. Okay, do we have time? Probably not. Okay. Yes, this is a recommendation of how to configure MySQL to be fail-safe. So basically, you should do three things. First one is sync bin log equal 1. It means that for each transaction, MySQL will try to flush it to disk. InnoDB flush log at TRX commit also 1. It also means that it will flush redo log. And last one is relay log info repository equal table. It's keep relay log position in InnoDB before, because in old versions it was stored in some file and it wasn't so reliable. Yes, probably it's defaults in MySQL, but it's better to explicitly specify. You should not be really worrying about flushes on every transaction, because if you have multiple connections to a database with a lot of concurrent transactions, MySQL is smart enough to combine several transactions in so-called group commit and write it at once and making one single sync to disk. And also in modern servers, you will have SSD drives that can be flushed really, really fast and open. So don't be really worried about this. Replication with GTIDS. GTIDS, it's global transaction IDs. It looks like UID of server and then ranges of transactions that came from that server and applied to some host. It's easy to install it from the very beginning rather than migrating from old positioning and offset approach. So probably you want to set up GTID mode on and enforce GTID consistency on. And then you can forget about that file log position and after position, use master after position instead of that. For semi-sync replication, it's a little bit more interesting. First of all, you should install semi-sync plugin. Probably it's by default installed and you will just use it. Then you should configure master and slave. For master, there are several options. First one is wait for replica count. It specifies how many replicas you want master to wait. Usually you want to set up this value, at least one, to have one semi-sync replica that in case of master failure will be new master. If you will have a lot of replicas, probably you may want to have to replicate your bin log events at least for all hosts and at least one host in another data center. So this the value will be the maximum number of hosts in single data center and plus one of this current master. Next interesting option is master timeout. This one is required because master is allowed to commit transactions after reaching this timeout. For example, after 10,000 seconds of not getting acknowledgements from replicas, it will commit without acknowledgement. In production, probably you want to make it infinity or as big as possible because You don't want master to acknowledge any transactions that it cannot reliably store. And finally, you should just enable it. For replica, it's very simple. You just enable it by slave enable equal 1. After that, it's required to restart your thread, and basically it will work as expected. Okay, what else MySQL provides? First one is delayed replication. So in change master statement, you can add source delay equals some time. It's a really interesting option because you can say, okay, we will have one replica with source delay equal to, for example, 25 minutes. Why do you need it? In case of you go into master and dropping some database, you will have 25 minutes to go to this replica, stop replication, remove unnecessary transactions, and say, wow, this replica is new master. And you will have at least one host with not broken data. Probably it will save you from disaster. MySQL supports replication filters. You can specify from which database events you want to apply. For example, master can have multiple databases, and on some replica, you will want events only for one database, maybe two databases, and filters will help you to reduce, to not fetch, not to apply events from database you don't want. Unfortunately, it's a bit fuzzy options, and it's not so reliable. Probably it can work, but there is no guarantees. And probably the most interesting one is multi-threaded replication. This one allows you to set up replicas to apply transactions concurrently, and it can speed up your replication quite well. So it's so generally it's quite safe and recommended to use. Okay, let's see how to handle issues. We have two magic commands: show slave status and show master status. Both of them prints current replication statuses, and in slave status you will see whether EO thread and SQL threads working. Last errors on these threads observed, and this is really useful because it will show you a lot of issues. Probably you will just Google it and will find quick solution. Probably not. And one more source of truth is MySQL logs. You will open logs and see what's happening. Okay. One popular issue when you're running show slave status, you see that slave is connected and blah, 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 but master has purged binary logs. It means that your replica is too slow, and when it connected, it's observed that master already removed that bin logs, and you don't have these bin logs at all. And here you can do little. Basically, the solution is to remove this host at all and set up it from very beginning, from new backup, and hope that master will have all bin logs. Also, you will go to the master and increase space and time of preserving these logs on master. Second popular is my favorite, I think, is when people on master host removing a lot of rows from some table, and surprisingly, this table doesn't have primary key. For statement-based replication, it will replicate just one delete star from my table statement, and it will work quickly both on master and on slaves. But for row-based replication, it will produce, for example, million rows updates, just million rows removes. And on master, it will work as single full table scan, but on slaves, it will run as 1 million full table scan to find this primary key. There is no solution for this when it happened, but you can prevent it by regularly checking your database schema for tables with no primary key. You can use MySQL shell to detect it, or you can go to the sources of MySQL shell plugins and find SQL script that detects tables with no primary key. Third issue is also quite interesting. The symptoms is replica got disconnected randomly. Some transactions on slave are absent, or some events duplicating. It can lead to data corruption in terms of MySQL complaints that some rows doesn't exist, or primary key duplicate, or something like this. It's a lot of crazy things. And basically, there are several, I know at least two reasons for that. The first one is non-unique server ID, because when transaction appears on slave, slave will think that these transactions produced by this slave and shouldn't be applied again. So it will just skip these events, and in the future, when server with different events from different server ID appears, it will just not be able to apply because no such rows in database. And solution is simple: set correct server ID, drop current database because data is corrupted, reset up from backup, and you will get things working. And second option is memory engine used. Surprisingly, it's not replication friendly, because whenever you restart MySQL, it will remove all the rows from memory engine tables. And when events from replication goes to your server, you will not have these rows. So it will work for inserts, but updates and deletes will fail. So rule of thumb, don't use memory engine when you have replication enabled in MySQL. This one is most complicated issue. It's when you think that replica is lagging behind and this lag is growing. In fact, you can do really little with this. You can enable multi-threaded replication. Sometimes it helps, sometimes it isn't, but just turn it on, it's free. Second option is shard your database or change your queries. So you should sit with your developers and think how you can deal with it. And as temporary solution, you can reduce durability. For example, set sync bin log to 100. It means that MySQL will do syncs to disk only once in 100 transactions. It's really bad for durability, because if master will crash during with this option set to 100, it will mean that you will probably lose some transactions, and it will be really hard to recover this master, and you will just pray that your replicas are okay. But it can significantly increase speed of the master or of slaves, and the lag will finish. Okay, wrap up. Okay, I will show you wrap up, and then if we will have 5 minutes to show how it looks in console. Okay, wrap up. MySQL replication is mechanism of recording changes and replaying this on replicas, and it's quite easy to configure and set up. Okay, now I will switch to my console window. Okay, I don't have window. Okay, I will share the whole screen. Okay, here is my setup of two hosts. First MySQL, second MySQL, and this one is just for benchmark running. Let's check the configuration. First of all, we should check that MySQL has different server IDs to work it correctly. Here it's not specified, but go to the MySQL itself and select server ID. We will see that this is 1. And on the second, etc MySQL. Okay. We'll see that I specified its server ID to 2 exactly, and so replication will be safe. Let's connect to MySQL. Okay. I will reset slave just to have it empty. No slave. I will show that. Okay, sorry. It's better to use G. So now it can be readable. And we see there is no replication configured. So basically, as you have seen, we should use change master 2. Okay, it's applied. And after that, we can start slave and hope that I haven't broken things. Show slave status. Okay, again. Now we can see here that we have master host, master binlog file, binlog events, and the most important that slave is running both IO and SQL. There is no errors. There is no errors. And current state is waiting dependent transaction to commit. So probably something happening. So it's completely fine. I think that we have quite limited in time. Do you have any? Okay, hello everyone. Okay. Do you have any questions, or I can show it a little bit more details how to configure it? Okay, you don't. Okay, I will show you a missing part that I haven't shown you before. It's how we can set up replica from the scratch. So first things I will okay, I think I don't share a screen. Okay, entire screen. Okay, share. Yeah. I will stop MySQL. Please stop. Okay, it's something weird happening. Unexpected. Okay, it stopped. Then I will remove I'm removing all content of MySQL database. So database is completely wiped out. Next thing I should, okay, and also I will remove data. Okay, what I will do, I will create a backup on the master extra backup. Yeah, I will specify backup because I'm creating backup, target directory, and user and password. Basically, this will make a backup of master host. To open target stream for extra backup log file. Okay, because here I also should remove old backups. Okay, it's running. Here I should say that extra backup is backup tool that creates physical backup on running database. So it copies content of database. And because MySQL will also write at the same time, extra backup will also copy redo log. It's log of all changes that InnoDB performs on the database. And then we will, because it happens at the same time, we will require to apply this redo log to our backup in order to have it consistent. Okay, I believe it's quite big backup, surprisingly. Okay. Copying third file. Next thing we will do, we will copy these files to Replica and apply redo log to this backup, and then we will be able to unpack it and use it. Okay. Wow, we have fourth file. Okay, let's check how many files do we have. MySQL. Permission denied. Oops. Okay. Actually, I don't see them here. EB data. Okay, we don't see them because it's inside IB data. Because I haven't configured to use separate files for each database and it use one table space. Okay, now we have time to answer questions. Thank you very much. Okay. Wow. Snap, proxy. We don't have. Probably it's root. 13 gigabytes. Wow, quite a lot. Surprising. Okay, let's check. Okay, here I removed. Okay, basically what will happen is extra backup prepare command will run. This will apply. We don't have here backup, so it won't work. And then we will just copy all the data to the correct place. Okay. Okay, let's copy it. Okay, it will take a while. And after preparing and then copying data, we will be safe to start MySQL. And then it will be complete copy of master. Then we will reset master, reset slave, and change master to master. Okay. Surprisingly. Okay. People is waiting. Do you have any questions so far? Okay, unfortunately, we're running out of time. I will finish this, but if you don't have time, so feel free to watch it in recording in X2 with X2 speed. Okay, let's continue seeing how it copies. Not so fast. 15 seconds per file. 10 files. Okay, 5 minutes. Okay, currently I will tell where these magic numbers as binlog file name and position get. It's stored in backup, extra backup info. Okay, as usual. Here we can see binlog position, file name, and position. So we will use it during master configuration. Also, we can see redo log position, but it's out of scope for current webinar. Okay, it's 7th file. Okay, we have time. Let's tell you about how, okay, window here. In theory, if you want to high availability configuration, you may also want to fail detection, master fail detection, and automatic failover. So probably you want to do it not manually, as I have shown you just now, but make it automatically. So you may use OpenArch Orchestrator. We haven't tried to use it because we used another tooling, and yeah, it looks like you can have a nice and you can configure it quite easily. And at Yandex, we used another tooling, MySync. It's absolutely command line and config based. It can be harder to use, but I have a lot of trust in this, and we worked with a lot of databases using it. Okay. Yes, we just copied everything. Screen share. Okay, we just copied. Now we should execute prepare data. It applies all redo logs to our backup. And copy back. Instead copy back, I will use move back. It will be a little bit faster. Yes, we did it, and now it's safe to start. Okay. Service MySQL start. Because control process var log MySQL log. What does it mean? Shutdown complete. Permission denied. Okay, yes, it was my mistake. We should change permissions to user MySQL for all data files because MySQL cannot read as root. Okay, MySQL user root password. Okay, reset slave because now it's incorrect. Here we should get these numbers, binlog number 5 at position 157. And now it's safe to use. Okay, we configured replication, show slave status. We see position, we see binlog name, and we see that slave not running. Start slave, we'll start replication. Okay, replica read everything and it's happy. User root. Okay. Let's create that database webinar. Okay, and it should be replicated. And database. Yep, we can see that it's replicated on another host. So as you can see, it's really easy to configure replication on MySQL. So I think that's all I would like to tell you about our application today. Probably next time we can talk about backups and some other interesting things. Thank you and goodbye.